All right. Good evening, everybody. My name is Amaan Shaikh, and today I will be talking about Dulcolax. So, this is just a quick overview of the presentation, just a quick little summary of all the things I'll be going over. First, I'll be talking about what Dulcolax is and what is its active ingredient. After we talk about that, we will soon go to discovery and treatment, molecular formula, and the Lewis dot structure. Then molecular and electron geometry, and finally, the closing. So, what is Dulcolax? Dulcolax is a laxative which stimulates bowel movements. It is typically used before any internal medical procedures, and it is also used to treat prolonged constipation. It's usually given for individuals who have prolonged constipation if they have not had a bowel movement in more than 2 days. It is sold as 5 milligram oral tablets for adult and children's, and as 10 milligram suppositories. Now, suppositories are tablets which are to be used up the rectum. When you use suppositories, they're a lot faster and you will have a bowel movement a lot sooner than if you were to take oral tablets. Dulcolax is made by Boehringer Ingelheim Pharmaceuticals, a pharmaceutical company based in Germany and one of the largest pharmaceutical companies in the world. Their net worth is well over billions of dollars. Now, Dulcolax was first used as a laxative in October of 1956 when it was approved by the FDA to do so. So now we get to what is the active ingredient. Now, the active ingredient is what we're going to be basing our Lewis dot structure and our ball and stick structure that I'll be showing you guys later. Bisacodyl. So Bisacodyl is known as a stimulant laxative. Like I said earlier, it relieves constipation by helping your bowels move so you can poo or have a bowel movement more easily. It also acts as a stool softener. Now, Dulcolax does make a specific line of products that act solely as stool softeners. Bisacodyl tablets, which are oral tablets, take 6 to 12 hours to work. That's why on the labels they suggest that you take it at night so first thing in the morning you are able to go. They are faster if taken as a suppository. Now, as previously stated, a suppository is a rectal tablet. It is used to clean out the intestines. Bisacodyl sounds very good in the sense that it'll help you get ready for medical procedures and relieve you of constipation, but that does not say that it doesn't come without side effects. Now, the most common side effects people have reported are nausea, diarrhea, and stomach pains. Now, these severe side effects are often rare, but that doesn't mean they don't happen. So the severe side effects consist of feeling dizzy, having rectal bleeding, or vomiting. Now, I'd like to present to you the Lewis dot structure. This is one that I have drawn out. So as we can see, the molecular formula is C22H19NO4, which is carbon 22, hydrogen 19, nitrogen, and 4 oxygen. Here is another Lewis dot structure that I made in MoleView. MoleView was a site that we used for one of our labs this semester. It's much more clear to see the different bonds between oxygen, carbon, carbon, hydrogen, and carbon nitrogen. On this slide, we will be taking a look at the bond types and the molecular and electron geometry. Now just keep in mind, when we talk about electron geometry, we will only be talking about the non-bonding pairs. So now let's take a look at our bond types. Our first one is nonpolar covalent, which consists of carbon-carbon with a single bond, carbon-carbon with a double bond, carbon-hydrogen with a single bond, and nitrogen-carbon double bond. Our polar covalent bonds consist of carbon-nitrogen single bond, oxygen-carbon single bond, and carbon-oxygen double bond. Moving on to our molecular geometry, we'll look at CH3, which has a trigonal planar molecular geometry with an angle of 120 degrees. We look at our carbon-carbon single bond molecular geometry. It is linear, has an angle of 180 degrees. HCN has a bent molecular geometry with an angle of 109.5 degrees. Finally, our carbon-oxygen single bond, which also has a linear molecular geometry of 180 degrees. When we look at our electron geometry of our non-bonding pairs, so we see that oxygen has a bent electron geometry and nitrogen has an electron geometry of trigonal pyramidal. Now we just take a look at a ball and stick model. So when we look at Bisacodyl, it is carbon 22, hydrogen 19, nitrogen, and oxygen 4. So that is a total of 46 atoms. In the bottom of the text box, I have a little key so you can take a look at what all the different atoms are. In gray, you have your carbons. In white, at the ends, you have your hydrogens. And if you look towards the middle bottom of the structure, you will see that there is one blue atom, and that is your nitrogen. The reds are your oxygen. And now this is just another ball and stick model from MolView, which I really like. You can really see the 3D view from here. The key is the same. The gray are your carbons, your white are your hydrogens, your blue is the nitrogen, and red is your oxygen. In this one, you can very clearly see the double and the single bonds, which is probably the main reason I really like this one. And finally, I would just like to give a closing statement just to go over the main points we talked about in this PowerPoint. So, Dulcolax is a brand name for Bisacodyl. Its molecular formula is C22H19NO4, and it is used for constipation relief and for draining the intestines before operations. Now, if you find yourself in the hospital before any type of operation and they ask you to take a laxative, whatever happens afterwards, just please say thank you to your nurse and your nursing assistants. They would very much appreciate it. So that is the end of my PowerPoint. I will be showing you my works cited in the next slide, but just as some final closing words, if you do have any questions about my presentation, please post them in the discussion board on Blackboard. I would love to help you with any questions you may have. And lastly, this is just my works cited of where I got my information. And right here in MolView, Our second citation, that is where I got my ball and stick model and my Lewis dot structure, which was not made from hand.